Good morning, doctor, and good morning, everyone. My name is Han Shomi, and I'm from Group 12. So today we are going to present about how hearing aids enhance the life of individuals with hearing loss.
So, hearing aids are small yet powerful medical devices that have managed to transform the lives of many people through restoring their auditory perception. In the 17th and 18th century, people used ear trumpets to act as a funnel to amplify sound waves that are entering the ears. At that time, gadgets like ear trumpets were still made from raw materials like wood or metal. In the 20th century, there was an American electrical engineer named Miller Reese Hutchison who invented the first electronic hearing aid known to mankind. The modern-day hearing aids are equipped with high adaptability and functionality to ease everyday life for the disabled. According to the World Health Organization, it is projected that by 2050, nearly 2.5 billion people out of the whole population will encounter some degree of hear loss. As for now, there is an estimate of over 1 billion young adults that are facing the risk of permanent hearing loss, also known as going deaf. This broadens the significance of the role that hearing aids play in the current community where people are beginning to neglect their own health and conditions.
Everyone knows about the ears, but did you know that ears is divided into three parts, which is the outer ears, middle ears, and also the inner ears. So I'm going to talk about the ears and also the functions. And the first one is the semicircular canals, which is inside our inner ears. So we detect about the angular accelerations and also the outer lip organs, which sense about the linear accelerations, vibrations, and also the head still relative to gravity. So the next one is the ear canals, which is will amplify the sounds and direct it towards the tympanic membrane, which is our eardrum. The next one is outer epidermal layers and also the inner mucosal layer. It will provide the protective functions. Next is the central fibrous layer. It will contribute to its mechanical strength and flexibility. The last one is the middle ear cavity. It will help to maintain the equilibrium in air pressure on both sides of the membranes, ensuring provide the proper sound transmissions. So the theories of hearings involve the Place theorem and also the traveling wave theory. We'll talk about it later.
Hi, my name is Xiu and I'll be presenting on ear impairments. So the first ear impairment is conductive hearing loss. It happens in the outer or middle ear, and it happens when sound cannot efficiently travel through the outer or middle ear to the inner ear. This can be due to earwax buildup in the ear, fluid from infections, or structural problems like perforated eardrums or osteosclerosis, as shown in the picture. The next one is sensory neural hearing loss. This happens in the inner ear or the auditory nerve. It is the most common type of hearing loss that happens in adults, and it happens from damage to inner ear or auditory nerve. Can be due to aging, which is called presbycusis, or prolonged noise exposure, especially if you attend a lot of concerts or loud music events, or you wear your earphones for a really long time, or certain genetic conditions.
Hello, my name is Kara Elena. So for my part, it's about hearing aids. So what are hearing aids? Hearing aids are an essential tool that restore auditory perception for millions of people with hearing loss, especially those with sensory neural hearing loss caused by aging, exposure to loud noises, or medical conditions. These devices amplify sound waves, allowing users to perform daily tasks, communicate effectively, and reconnect with the world around them. So hearing aids consist of three components: a microphone that collects sound, an amplifier that enhances it, and a speaker that delivers processed sound into the ear canal. While this sounds simple, modern hearing aids integrate advanced technologies. For instance, digital signal processing, or DSP, enables precise and control, while adaptive feedback suppression eliminates whistling noises. So directional microphones further enhances the user experience by separating speech from background noise, and wireless connectivities allows seamless integration with smartphones and other devices. So recent advancements have also introduced artificial intelligence into hearing aids. AI-powered algorithms analyze auditory environments in real time and automatically adjusting settings to ensure optimal performance in both quiet and noisy conditions. This personalized approach ensures that users can transition smoothly across various environments, improving not just hearing but also their quality of life.
Hello doctor, my name is Nur Shahira binti Muhammad Zaki. Today I'll talk about the functionality and suitability of hearing aid. First, let's see from amplification and sound clarity perspective. Hearing aid use DSP technology to analyze incoming sound wave. Also, hearing aid use automatic noise reduction to amplify speech while suppressing background noise. Next, let's move on to compatibility with hearing loss type. I have listed a few types of hearing aid for different type and degree of hearing loss. First, bone-anchored hearing aid used for people with either conductive, mixed, or unilateral hearing loss. Second, cochlear implant for people with severe to profound hearing loss. Third, auditory brainstem implant for people have hearing loss due to severely abnormal inner ear. Last, in the canal hearing aid, suitable for people with mild to moderate hearing loss. Besides all these things, correct fitting is important to maximize effectiveness, ensuring optimal audio enhancement. Different hearing aids need different fitting based on people's ear. Improperly fitted devices will bother the function of hearing aid.
Next slide I'll be presenting on is the limitations. So the first one is application and sound clarity. So hearing aid when installed in your ear, it helps to amplify all sound, including background noise, which can make focusing on conversations in noisy settings difficult, especially when you're eating in a noisy restaurant or you're in a noisy outdoor setting. While the hearing aids may help you to hear conversations better, it also amplifies other people's conversations, which makes focusing on the conversation you need to hear very difficult. It also may cause distortion, particularly for severe or profound hearing loss, and feedback can occur with improper fit or settings. The next one is compatibility with hearing loss type. So not all hearing aids are suitable for all types of hearing loss. Like some types of sensory neural loss may require cochlear implants, and some types of conductive loss may benefit more than something than hearing aids. Or conditions like mixed hearing loss might require different conditions or different settings with different devices in mind. The next one is fit and comfort. Poor fit can cause discomfort or reduce sound quality, with some models unsuitable for small or irregular ear canals. Some hearing aids may be a bit too small and it might fall out your ear easily, and smaller devices may lack durability, and maintenance can be challenging for those with dexterity issues, especially those old and elderly. It may be a challenge for them to put on hearing aids every day in the morning. Adaptation periods also can be lengthy, and aesthetic concerns may deter some users despite design improvements. A lot of people don't want it to be shown that they are wearing hearing aids, so this might be an issue for a lot of people.
Let's begin with the challenge. Despite advancements in comfort and aesthetics, hearing aids still struggle to significantly enhance speed perception, especially in noisy environments. While they restore audibility, the clarity of speed often remains poor. Another issue is the occlusion effect, where users perceive their voice as hollow or echoing due to trapped sound pressure in the ear canal. Lastly, while hearing aids use algorithm, the system natural intelligence or learning ability. Techniques like neural networks and fuzzy logic are being explored to create smarter design in the future. Now let's move to the improvement. Innovations in microphone design have led to better performance. Automatic directional microphones seamlessly switch between omnidirectional and directional modes without major adjustment. Adaptive directional microphones dynamically respond to noise by adjusting polar plots based on acoustic input. Multi-canal adaptive directionality incorporates multiple frequency canals to improve performance in diverse environments. Finally, asymmetric directionality use a combination of directional and omnidirectional microphones in different ears, enhancing focus on specific sound while maintaining environmental awareness.
The materials used in hearing aids are just as important as their technology. Traditional materials like rigid plastics and metal provide durability but often fall short in comfort and resistance to environmental factors. Users commonly report discomfort from prolonged use and also device failures caused by moisture or dirt. So innovations in materials have addressed these challenges. Hydrogels, for example, are flexible and biocompatible, conforming to the contours of the ear canal to reduce pressure and irritation. So they even include antimicrobial properties, including reducing infections associated with extended use. So another groundbreaking material is graphene, so which is incredibly light, strong, and conductive. It enhances sound quality and enables thinner, more discrete signs. So to tackle environmental exposure, moisture-resistant coatings have been developed, improving device durability under humid conditions, especially in our country. Sustainability is also a focus, with biodegradable polymers and recyclable metals reducing the ecological impact of hearing aids. Looking ahead, piezoelectric materials offer the potential for self-powered hearing aids, eliminating the need for batteries while ensuring reliability. So these advancements combine to create hearing aids that are not just functional but comfortable, durable, and environmentally conscious.
Now I'll tell about future of hearing aid. Maybe in the future, hearing aid will have lots of connectivity to other applications. That might be an increase in wireless technology. Besides, the quality of sound has greatly improved. The development of assistive devices offering further clarity for hearing aid user. Moreover, future hearing aid use AI to process and adjust sound in real time, tailoring sound experiences to the user's preferences and the environment. Maybe in the future, hearing aid will have individualized fitting system. This allowing fine-tuning to be done automatically outside the office. Hearing aid also can turn into very practical medical instrument that keep providing a real-time response. And last one, this device could combine two features, invisible but still equipped with many features.
In conclusion, hearing aids have made significant advancements in both functionality and design. Modern hearing aids offer enhanced sound quality, improved user comfort, and greater utilization of digital technology. Although limitations such as battery life, size, cost, and issues regarding sound clarity in environments with greater noise are still yet to be solved, future innovations and improvisations in terms of materials and designs such as integration of lighter weight, durable, and eco-friendly components, combined with the use of more advanced technology like stronger noise cancellation and better personalizations to fit every user's needs, are seen as potential areas to be discovered. Additionally, the incorporation of AI and machines can further optimize the performance of hearing aids, making them more versatile, offering more responsive and effective solutions. As technology continues to evolve, hearing aids have a promising future, making them one of the widest usage medical devices in our community, with greater accessibility and more seamless integration into daily lives.
That's all from our group 12. Thank you.